Good wishes to all and welcome to today's class. Today we are going to study about periodic properties. What do you mean by periodic properties, or what do you mean by the word periodic? Periodic means anything that repeats after a regular interval is called periodic. Is it not? You might have studied about the periodic motion. What is periodic motion? If a motion repeats after a regular interval, it is called periodic motion. You might have studied it. Example, movement of the earth around the sun. Is it not? This is periodic. Like that, if anything repeats after a regular interval, it is called periodic. And this behavior is called periodicity. Okay. Now, what are the periodic properties we are going to study in this lesson is atomic radius, then ionic radius, ionization energy, electronegativity, electron affinity. All these things show a periodicity, and therefore we call these properties as periodic properties. Okay, and we are going to study about these properties in today's class. What is atomic radius? First we are going to study about atomic radius. Atomic radius of an atom is defined as the distance between the center of the nucleus and the outermost shell. Okay, distance from the center to the outermost shell of an atom is called atomic radius. Okay, it is not possible to measure the radius of an isolated atom. So, we will be considering two atoms, two neighboring atoms, and the distance from the center of the one atom to the center of the other atom we can measure, and half of that will give us the atomic radius. Okay, except for noble gases, usually the atomic radius is referred as covalent radius or metallic radius, depending on the nature of the bonding between the concerned atoms. Now, atomic radius in metal atoms is known as metallic radius. It is half the distance between the nuclei of adjacent metal atoms. You know, almost all the metals are found in singular atoms, is it not? That is, if we take sodium, Na, we won't write Na2, sodium will be Na. So, in an element, the atoms will be arranged in a regular repetitive manner, and we will find the distance between the center of the one atom to the center of the other atom, and half of that will give us the metallic radius. Okay. In non-metallic elements, their atomic radius is known as covalent radius. For example, if we consider hydrogen or nitrogen or chlorine, these atoms will be combined together. Hydrogen means there will be two hydrogen atoms, is it not? Two hydrogen atoms will be there, and chlorine, two chlorine atoms, nitrogen, two nitrogen atoms. So, these two atoms will be combined together using a bonding called covalent bonding, and therefore we will be finding the radius of such atoms by taking the distance between the two nuclei of the atoms, and half the distance will give us the radius. Okay, so this is called the covalent radius. Okay. Now, let us consider hydrogen molecule. Okay, hydrogen molecule contains two hydrogen atoms, and the distance between two hydrogen nuclei of the molecule is 0.74 angstrom. What is 1 angstrom? 10 power minus 10 meter. Therefore, this distance is 0.74 angstrom. Therefore, how will we find the radius? Half the distance, that is 0.37 angstrom. Okay. When we look at the table, along the period, the atomic radius of the elements decreases along the period. Period means from left to right, the atomic radius decreases, and from top to bottom, that is along the group, atomic radius increases. Okay, along the group, each element will be having one more new shell. Therefore, atomic radius obviously will increase, is it not? But this may be a doubtful situation for you, because number of electrons increases along the periods, but I am telling atomic radius decreases along the period. Let us take these two examples, lithium and boron. This is lithium having 3 electrons and this is boron having 5 electrons. In the lithium atom, the outermost shell has only 1 electron and the inner shell has 2 electrons. And this electron, as it is very much free to move, it will have a less attraction towards the nucleus, and therefore it will have a larger radius. But here the outermost shell has 3 electrons, and these 3 electrons can have some more close attraction towards the nucleus. Therefore, they will be moving towards. Therefore, the atomic radius between these two is which one has a more atomic radius? Lithium, and boron has less atomic radius. This will be the radius. Now, okay, this is how the atomic radius decreases along the period in a periodic table. Okay. Now, ionic radius. What do you mean by ion? Yes, if an electron is removed from an atom or added to an atom, that atom will become ion. Is it not? This you might have studied. Now, lithium. The same example, lithium. Lithium has 3 electrons, 2 in the first shell and 1 in the next shell. And it is easy for us to remove the 1 electron from the outermost shell, and lithium will become Li plus. Okay, because now lithium has 3 protons and 2 electrons. 1 proton is more, therefore it is Li plus. Likewise, sodium, atomic number, yes, 11, and it will be having configuration 281. Now this 1 electron in the outermost shell can be easily removed, and it will become Na plus. That is 11 protons and 10 electrons. Therefore, it will become Na plus. And here, this fluorine has how many electrons? Yes, 9 electrons, 2 in the first orbit and 7 in the next orbit. And this fluorine can attract 1 electron, and now it will become fluorine ion. It has 10 electrons in the shell and 9 protons. 1 electron is more. Therefore, it will be F minus. Likewise, chlorine. Chlorine has 17 electrons. So, it can attract 1 electron from any other atom, and it will become an ion. These ions are negative ions. Now, we are going to see how the ionic radius varies along the group. Like in the atomic radius, ionic radius also decreases along the period and increases along the group. But when an atom is converted into its ion, its radius decreases. See, lithium, the atomic radius of lithium is 156 picometer. Pico means 10 power minus 12. Okay. And when it becomes a positive ion, the atomic radius becomes, that is ionic radius, and the ionic radius is 90 picometer. Likewise, fluorine atomic radius is 69 picometer, but when it becomes ion, it is 119 picometer. Okay, so for positive ions, ionic radius decreases, negative ions, ionic radius increases. This is how ionic radius changes, and as I told you, ionic radius decreases along the period and increases along the group from top to bottom. Now, ionization energy. What is ionization energy? Ionization energy is the minimum energy required to remove an electron from an atom. It is measured in kilojoule per mole. If ionization energy increases, it will be difficult to remove the electrons. Okay. What is ionization energy? Energy required to remove an electron from an atom. Now, this is lithium electron. We are removing an electron from this lithium. Therefore, lithium becomes Li plus. Okay, Li plus. And this Li plus, in order to remove the electron, there is some energy needed. That energy is called ionization energy. Ionization energy increases along the period but decreases along the group. Ionization energy increases along the period because when the atomic radius increases, it is easy for the removal of the electron. So that is why ionization energy decreases along the group. Ionization energy increases along the period but decreases along the group. That is, if the atomic radius decreases, more will be the energy needed to remove an electron from it. Therefore, ionization energy will be more along the period. But when the atomic radius increases, the attraction from the nucleus is becoming less, and therefore it is easy to remove an electron from the outermost shell, and therefore this ionization energy decreases along the group. Okay. Now, electron affinity. Electron affinity is the amount of energy released when an atom gains an electron. It is also measured in kilojoule per mole. For example, let us consider fluorine atom. Fluorine has 9 electrons, 2 electrons in the first orbit and 7 electrons in the next orbit. Now, if we add an electron to this, some energy is needed, is it not? And that energy is called electron affinity. Okay. Now, what will happen to this atom? Fluorine atom will become fluorine ion. Okay. So, this is called electron affinity. And next one is electronegativity. Electronegativity is the measure of the tendency of an atom to attract its shared pair of electrons towards itself in a covalent bond. For example, let us take hydrogen chloride, hydrochloric acid or hydrogen chloride. What happens here is hydrogen having a single electron in the outermost shell can give its electron to chlorine. That is, they are forming a covalent bond with each other. Chlorine having more electrons can attract this electron towards itself. Okay, they will have a bonding, but the outermost electron of hydrogen will be taken by the chlorine. There will be a strong pull for the electron by the chlorine. Therefore, this is called electronegativity. This is called electronegativity. Now we can make it in a nutshell. The periodic properties such as atomic radius and ionic radius decreases along the periods from left to right, but increases along the groups from top to bottom. The other three properties such as ionization energy, electron affinity and electronegativity increases along the periods from left to right, but decreases along the group from top to bottom. Okay, we can see it in the table. Atomic radius decreases from left to right, but atomic radius increases from top to bottom. Likewise, ionic radius decreases from left to right and it increases from top to bottom. Then ionization energy decreases from top to bottom and increases from left to right. The other two properties such as electron affinity and electronegativity also increases along the period but decreases along the group. Okay. With this, we conclude the topic. Now I am asking a single question. The elements of the third period of the periodic table are given below. What are the elements? Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. Okay. Which atom is bigger, sodium or magnesium? Which atom is bigger? Sodium. Why? Because the outermost shell of sodium has one electron and therefore it will have somewhat less attraction, but magnesium has 2 electrons in the outermost shell, so it will have more attraction towards the nucleus. Therefore sodium will have more radius. Okay, now identify the most metallic and non-metallic element in period 3. Okay, this is the third period elements. Which one is the more metallic? Sodium is the more metallic. Why it is more metallic? Because it can form molecule with any other elements by releasing one electron. And non-metallic, more non-metallic is chlorine, because by attracting one electron it can become an ion. Therefore this is more non-metallic. Okay. So with this we are concluding today's class. Thank you.